Hello everybody. Once again I am here with you for the last point of this fourth unit, that is communication electronics, and we are looking for the characteristics of radio receiver. Two characteristics, selectivity, sensitivity we have seen. Now the fidelity. Now fidelity is simply it is nothing but to be ability of receiver to reproduce all the modulating frequencies equally, and that is what the fidelity is. That means to be whatever be the this is simply as an receiver's ability to regenerate or the reproduce all the modulating frequencies in a equal frequency range, and that is to be giving definitely a flat curve in this case. And the fidelity basically depends on the frequency response of the AF amplifier, and the typical fidelity curve is shown here in this diagram. And if you look at this case, where the along the x-axis there is a frequency, and here is the receiver output in dB, and if you look at, this is the flat response or the flat curve is there, and that is somehow receiver's ability to all the reproducing all the frequencies in a equal frequency range. So as far as the calculation or the measurement parts or the high fidelity is essential in order to get the good response for the music, um, in without introducing any distortion, noise, and that is essential to have a frequency response over a wide range of audio frequency. And fidelity curve for a receiver, as shown in the previous diagram, we have seen the frequency response of AM amplifiers stage in the receiver. Basically amplifier AF amplifier, at this stage this receiver should work in this fashion. The produced to plot the fidelity curve is what conditions are there and what is the procedure is there. Simply as the previously we have seen the experimental setup regarding the uh, previous two whatever be the our characteristics we have seen in the same way. And the adjustment of the modulation is here should be 30 dB, modulation should be 30%, and the carrier frequency here it should be 1000 kilohertz. Now keeping these constants, we have to manage the inputs voltage as an constant throughout the fidelity measurement. We have to keep it as it is constant. Now adjust the modulating frequency to 1 kilohertz, and uh, whatever the modulating frequency we have to maintain at the 1 kilohertz, and adjust the output voltage to get the maximum undistorted output, and keep this voltage constant throughout the whatever experiment we are performing. So this is simply as an same part is there what we have seen in the selectivity and sensitivity part. Again we have to keep modulating frequency FM, that is to be 1 kilohertz, and adjusting this to be maximum output voltage, to adjusting the output voltage to get the maximum distorted without distorted line, and to get this frequency modulating frequency 1 kilohertz. The whatever be the experimental throughout we are performing, we have to keep it constant. Again vary the modulating frequency from the 100 hertz to the 10 kilohertz, and suitable steps measure to receiver output should be every time, and convert the receiver output into dB and plot the fidelity curve as shown in the previous diagram. Here is the observation table, and where the modulating frequency is going to be introduced from 10 hertz to 100 hertz to, here is the mistake in the printing, it should be 100 hertz not the kilohertz, 100 hertz to 10 kilohertz, and receiver's output you should measure, and that will give us important about this fidelity. It should give us a flat curve, then it is to be that is essential for the good fidelity or the high fidelity is there. And the fidelity curve should be flat over the audio frequency. I already told you, because that gives you the fine response as far as the audio frequency or the music is going to be concerned. So thank you for joining this session. Be at home and be safe. Thank you.